Hello, my name is Fred Cohen, and I'm going to talk today about a program overview and perspective of the Webster Cyber Explorers program. This is an outline of the presentation. The genesis of the Cyber Explorer program was the College Cyber Defenders at Sandia National Laboratories. I started this program in 1977 when I was asked if I could use some students by the Education Programs group from Department of Energy. And I said, sure. They said, how many do you want? And I said, as many as you can afford. There's no limit to the number of useful things I can get done with more people. So they said, let's start with 4 or maybe 5. So I think it was 4. Local junior college students were in the program. We started at an old secretary's desk in a trailer that wasn't being used for anything else. The staff time came from my budget, which is basically my time at that point. By 2000, I was a principal member of technical staff. I had 35 students in the program. It was expanded to New Mexico. We had $250,000 a year in budget just for the students, and another $400,000 in research budget from my research program that went into the program. 60 Minutes came by. They did a segment on it. The president almost visited, but the White House staff did visit. And based on the College Cyber Defender program, they started the Cyber Corps, using us as a model. And that's the program that's largely working today to help build the capacity of the United States in defending the cyber environment. And by the way, it's still operating at Sandia. It's now a national center. It's the Center for Cyber Defense. Who are the Cyber Explorers? They're students trying to explore cyberspace. They're smart, interested, active, thoughtful, hardworking, motivated explorers. They want to find what others have missed, go where nobody's gone before, and hopefully they're not afraid to fail because there's certainly going to be failures along the way. We're not trying to get everything right. We're trying to learn and learn from our mistakes. And if you're not making mistakes, you're not trying something that's new and innovative. And of course, the faculty and staff, we'll call them leaders, are exploring with them. So, why should we do the Cyber Explorers? Well, there are lots of good reasons. Of course, for Webster, it helps to identify and develop smart, interested, intelligent, hardworking young people. And hopefully then they'll come to Webster and grow over time and become some of the best students, and ultimately maybe go to graduate school at Webster and move on to fabulous careers. So it builds the pipeline of students for higher levels. It gives practical experience to the students. Very important that the programs they work on in the Cyber Explorers aren't just book learning. They're building real things that have real applications for real problems in the world. And hopefully, as they do that, they learn to do better in jobs when they graduate. They get a better sense of what that's about, and they make all the mistakes early. It produces better, faster, cheaper research and development operations for the university. That helps us at Webster build bigger and better programs over time, and do so with limited resources, which is something we definitely have. It's also, of course, fun, engaging, and beneficial for everybody. The students and the leaders love what they do and want to do more of it. Employers get better graduates, and the graduates get better jobs. So, what is the program? Basically, it engages students to explore. So we have leaders that teach students, and then the students teach other students, and then ultimately the students teach the leaders. Because we're all in the program to learn and grow. And as an example, just getting online, the first thing we did was, taught students to build computers and load the software on them. But then, of course, the students taught the next group of students to do the same thing. And as the equipment improved and the software changed, the students that were teaching other students and learning came to know more than I knew and taught me about the next generation. So it helps everybody stay up to date. And of course, everybody gets a chance to learn and teach others and learn from others. It also, it's important to understand it works on a project basis. The projects are either research or operations. So we might be doing a project to improve operations of the Cyber Lab or the infrastructure we use for the Cyber Explorer program, or doing research on whatever people are interested in. We develop group projects together. The students execute with guidance and feedback and present it and propose more research. And so we're all sort of learning to explore together. This is, of course, at Webster University. We're going to be starting at the main campus with sophomores and juniors. I'll get into more details of that later. Expanding to central St. Louis, hopefully we'll engage high school and freshmen through that process, and then expand internationally, probably first to Europe or Africa, and then the other one, and then eventually everywhere. We're hoping to start this fall, expand as we make progress, and to have it led by an experienced team of people in this space. How does it work? Well, the typical projects that you see will be, for example, to build a secure, resilient file server and then use it to run those cyber programs at Webster. Build a cyber lab module, which is a component of the cyber lab intended to be reproducible. So when we build a module on site and then create better ways to manage that module, then the Cyber Explorers program will ultimately help to deploy the cyber lab Webster-wide. And that, of course, reduce the cost of operating the cyber lab at larger scale. Another example would be build a quadcopter control interface and use it to support remote physical management of the lab. Suppose you have a quadcopter with a little robotic manipulator on the arm that can plug and unplug things or power things on and off as necessary. We're hoping to build a model financial system. This is based on the knowledge that we have of how real financial systems work, but intended to have different protocols and different specifics so that anything you do with this model will not be directly applicable to the world, but you'll still learn and understand the underlying issues. And then, of course, we wanted to test out attack and defense on financial systems because they're part of critical infrastructures. Another example, we'd like to build a 3D printer CAD system to help build components for a robotics lab. So you can imagine that, of course, these projects build on each other over time. So as you get the 3D printer printing special purpose components that are just right for doing the particular functions associated with computers, you might find ways to attach them to quadcopters, and maybe you ultimately help do chemistry experiments remotely by having a chemistry lab, or whatever. That's part of the issue is we don't know what it's going to be, and that's why we want to explore. So now you have to keep such a program alive. It's not enough just to do a project. Once you do a project, it's going to die if the people that created it don't stay with it, or if somebody else doesn't take it over. So there's a fundamental requirement that you document what you built. And this allows you to teach others what you did and how you did it so they can then run it. And of course, they need to not just operate it, but improve it over time, and then they need to teach it to the next group of explorers. So everybody along the way is building and improving on the prior documentation. But of course, part of the build is building the way you teach others how to use it and how to build it. So the presentations are required for every project. It also, of course, teaches the participants how to communicate better, which we have identified as fundamental to success in the real world. Clearly, if you can't communicate effectively, you're not going to be as effective throughout your life and career. Projects are done in groups, so students learn how to work together. And of course, every student over time works in a group run by somebody else and runs a group that other people work in. And of course, these are other critical skills to success in the world, being able to work collaboratively with other people, lead and follow effectively and participate on an equal basis. And of course, it's not just the students, it's also the leaders. Leaders start projects, but leaders also work on other people's projects. How do we teach this? Well, we have educational content. We have recorded lectures and slides on special topics. Also, we hope to engage graduates of the program, but certainly the leaders, the students, and other guest lecturers participate in the educational program. And the program is very broad. It's not just on computers or cyber stuff. It's science and psychology and all sorts of things. Psychology, of course, is very important to understanding how to communicate effectively, and many students, especially in the computer arena, lack an understanding of how to operate in groups and how to be effective in groups. And so those elements of how to interact with other people are a very important part of the educational program. Also, of course, individuals and group activities have to be undertaken. So you build and maintain the computer that you use and the Explorers infrastructure, but you also might participate in projects like dumpster diving and reconstruction of whatever was in the dumpster. You have to build and tear down experiments, and not just the mechanics of it. You have to understand why things work, understand how to calibrate equipment, understand how to test it, so that before you do an experiment, you have to calibrate and test and run an experiment with the blanks, so you can make sure that you know what's the difference between what you did in the experiment and what would normally happen without the factors at issue in the experiment, and of course test it afterwards to make sure that the experiment didn't modify the equipment so that it doesn't work the same way anymore. And of course you have to propose and do report writing and budgeting and presentations. And everything that you learn, you have to teach somebody else. And this comes from a fundamental notion that you don't really know until you've taught somebody else. And of course, it's not just the leaders teaching the students. As the students develop, they come up with ideas. They start working on somebody else's project, then they propose and lead their own projects. And the people that are the leaders of the program, they're not just there to lead the students through these processes, they're there to learn as well. So ultimately, the leaders learn from the students. Particulars. So recruiting and admissions, starting with a core group who meet the admission criteria and commit to staying. We want them to be there for some number of years so that we can build a successful program and have them as the seed corn for growing the next generation of people in the program. So we can't really start with seniors because by the time they learn, they're graduated. So we need to start with sophomores and juniors. And it's a year-round activity, so it's not just during the semester. They want to have them there during the summer and then into the next year. Perhaps part of a work-study program or some other funding source to make that work. And then they'll help recruit the next generation, freshmen, high school seniors, students from other universities. And as they lead this, ultimately they're going to graduate and they're going to get careers where they turn their employers into believers, and hopefully their employers will help bring more funding or projects or students into the program. And then, of course, some of them will go to graduate school where they can continue to participate, as members of the Cyber Explorers or perhaps as leaders. As students develop over time, we've found that they're the best teachers. Of course, they advance their knowledge, skills, training, experience, and education and become the experts in the way the Cyber Explorers work and all the infrastructure and everything else about it. It's good for them and it's good for us. But eventually, of course, they have to move on. When they move on, we want them to keep in touch and continue to participate, both as alumni, guest lecturer, and guest faculty, but also hopefully they'll bring in special projects from their companies, perhaps projects that the company's not sure they want to spend a lot of resources on. They just want to explore it or learn about it or understand it. And of course, bringing Cyber Explorers to their companies, because of their connection with the Cyber Explorers. Hopefully the companies will be very interested in having more of these outstanding students with this wonderful educational experience and bring them in. And ultimately, of course, the goal for us is lifelong learners and teachers. Our expectations are quite high. We expect every student to learn the basics quickly. They have to work supporting the program. They have to bring their own ideas and learn to execute them, learn to work with others, learn to lead others, and they have to stay in school with good grades throughout the program. But it's not just the students, it's also the leaders. Every leader has to come expecting to learn as well. And the students are going to teach the new leaders the basics of the Cyber Explorer program, and the leaders have to be willing to learn from the people they thought they were teaching. Every leader has to work supporting the program, work on projects. They have to bring their own ideas, but they also have to work on student ideas as a team member. To start the program, we're going to be using the people that started the program at Sandia National Laboratories. That's me and Garrett G., who was an original student in the College Cyber Defender program. He also led major projects there, ended up as the lead student for a period of time. Ultimately, went to work for the Federal Reserve Bank in San Francisco and led their red teams and solution developers, helping to improve cybersecurity for the U.S. national financial system. And he still does that today on a consulting basis. And we're very fortunate that he's offered to spend some of his time working for us for significantly less than what he gets on a consulting basis, helping to build both the Cyber Lab and the Cyber Explorer program. One of the benefits of having people in such a program is that they really enjoy it and they become dedicated to moving it forward. Over time, of course, we want to transition it to a global Webster program, which means we're going to need leaders from around the world and students from around the world. And hopefully the students in our program, as they go into the international program and spend a semester or a year abroad, will bring the Cyber Explorer program with them. And hopefully students from abroad will come in and join the Cyber Explorer program and bring that experience back and help us to build the Cyber Explorer program on a global basis. That's the end of the formal presentation. I want to thank you for your time, and I welcome your questions and our discussion, but I'm going to turn off the recording.